Gonna go dancing.
I even labeled
All right. So how did everyone find that? Is that good? Mostly good?
Saw some good things on people's pages, and it's all right if you didn't get some stuff. It's okay, it's all brand new stuff. Okay? This is why we're doing this. Okay? Instead of you having to learn this at like summit time. Okay? It's nothing different. I'm gonna ask you on the summit to do that. If you didn't get something, just jot it down on the solution page. Okay?
Yeah, so we'll start with the take-up with number 1. So for number 1a, we want to develop a rule or equation that represents the following pattern. So it's a growing pattern where we've got boxes of 2 colors increasing. So we've got, essentially in figure 1, we've got 6 blue boxes and 1 yellow box, or I guess on your page, 6 dark ones and 1 light one. But overall, that's 7 boxes in figure 1. Figure 2, on the other hand, that's got 2 times 5, so 10 blue boxes and 2 yellow boxes. So that's going to be 12. For figure 3, then, we've got a total of 2 times 7, so we've got 14 blue boxes and 3 yellow. So that means we've got 17 boxes total. What this means is that every time we increase the term number, we're adding 5. So we can say that our multiplier is going to have to be 5. So the number of boxes is going to be equal to the term number times 5. And then it's going to have to be plus something, because the first term doesn't have 5 boxes. The first term has 7 boxes. The second term doesn't have 10 boxes. It has 12. So to completely express the pattern, we need to say that it's the term number times 5 plus 2. You could also express this as 5n plus 2, where n is the term number. Either one is totally valid. Any questions about that? Great. You could also do separate equations for the light colored and dark colored boxes, where the number of light colored boxes is the term number, and the number of dark colored boxes is the term number times 4 plus 2. But the most correct way is to just express all of the boxes all at once in a single equation. So that's what we'd be looking for. And then for part B, using your rule or equation, how many boxes would be in figure number 23? So the number of boxes is just going to be equal to 23 times 5 plus 2. And so that's 115 plus 2 to 117. Therefore, there are 117 boxes in figure 23. It's always important to have a concluding statement in this one, in these kinds of questions. Just really hammer home what is the answer here. What do you want the teacher to look at when you're marking? But yeah, so that's pretty straightforward, I think. Any questions about that? Great. So now we're going to use a table of values to plot the following line. Y is equal to negative 2x plus 3. And as Mr. Mackay said, essentially this column is the x column, and this column is the y column. So we're going to put all of our y values on the right-hand side for the corresponding x values on the left. So essentially all we have to do is take these x values and substitute them in to our equation. So if x is equal to minus 2, then y is going to be equal to minus 2 times minus 2. So minus 2 times x. So minus 2 times minus 2 plus 3. And that's going to be equal to 4 plus 3, which is then equal to 7. For minus 1, we plug minus 1 in, and we get minus 2 times minus 1. That gets you 2. 2 negatives make a positive. Then add 3, we have 5. And then we can carry on. So for 0, it's going to be minus 2 times 0. So obviously, it's just going to be the constant. It's going to be equal to 3. Then for 1, we have minus 2 times 1. This is minus 2. It's going to be a negative number this time. So then that will be equal to 1. And then last but not least, we have minus 2 times 2 plus 3. And so negative 2 times 2 is negative 4, plus 3 is just going to get you to negative 1. So this is a good example of a decreasing pattern. All right, so now that we have this table of values, we can use these values to start plotting the line. Before we plot anything, though, I think we just want to clean up the axes a little bit. So you always want to label what your y and your x axes are, especially if you're doing a word problem and it really, like y is not necessarily just y, but it has to do with price or something. You want to label that on the axis. Or if x has to do with time, you want to label that on the axis. But in this case, we just have y and x, so that's perfectly good. And you also want to make sure that you label each axis with the scale. You don't have to label every single one, so I'm just labeling every other tick mark here, just so you know that every tick mark it's going to go up 1. But yeah, you really just need to label it enough that whoever is looking at it can understand what your scale is just by looking at it. But yeah, so now that we've done that, we can plot these points. So our first point is going to be negative 2 and 7. So we have x value of negative 2, y value of 7. That just comes from the first point in our table, obviously. Our second point is going to be x is equal to negative 1, so just 1 across, and y is equal to 5. So it's going to be there. And then we carry along. So we've got 3 when x is 0. When x is 1, y is also 1. And then when x is 2, y is negative 1. So that gives us 5 different points. And that's plenty as far as actually getting a line out of that. So we'll do something like that. Obviously didn't do this exactly, but that's plenty close enough. So there's our line. A couple other things to mention here. We have the arrows on either end of the line, just to indicate that the line goes on forever. It goes on past this graph. The other important thing is you want to actually label the line as y is equal to negative 2x plus 3. This is especially important if you have multiple lines on a graph. But even if you have one line on a graph, the convention is you should write what it is on the graph, just so, again, it's abundantly clear what you're doing to anyone who's looking. But yeah, that'll be good for number 2. Does anyone have any questions there? And again, the line, it doesn't look fully exact, but that's okay. All right. Up next, we've got number 3. So we've got 2 equations now that we want to plot. We've got y is equal to negative 3x plus 4, 3x minus 4 even, and y is equal to, excuse me, y is equal to negative 1/2 x plus 13 halves. Sorry about that. So again, first thing we're going to do is clean up our graph. So we've got our y there, we've got our x there, and then we can label our axes. Okay, and then you can take whichever approach to graphing lines, whatever makes the most sense to you. So personally, I like doing what we were doing yesterday and just plotting the constant and using the slope to figure out what our line's going to look like. So I'll start with the first one, y is equal to 3x minus 4. So our constant is minus 4. So that means that that point exists, minus 4 comma 0. Or sorry, 0 comma minus 4. And then we know that our slope is 3. So we can go across 1 and then go up 3 and plot our next point there. And then we can go across 1, go up 3, plot our next point there. And so on. Next point, next point. And you can even do 1 at the bottom there if you like. So there's all the points you need for this line. So we can plot that right on. Again, do it as best as you can. Mine's not exact here, but that's going to be your line. And we can say that that is y is equal to 3x minus 4. Like I said, it's become super important to label your lines if you have multiple lines on the same graph. Other things we know about it, so we're listing all pertinent information here. So we also know that the slope of this line is going to be 3. And the y-intercept is minus 4. So those are kind of your important, pertinent pieces of information. Because these are, you essentially only need these two numbers to define any line. If you know the slope and the y-intercept of a line, you can draw it on a Cartesian grid. That's that. Okay, and then we can draw our second line. So we have y is equal to negative 1/2 x plus 13 over 2. So that 13 over 2 might cause you a bit of a pause, but you just have to think that 13 over 2, if you convert this to a mixed number, that's going to be equal to 6 and 1/2. Or if you just divide it, you get 6.5. Two approaches to the same thing. And 6.5 does seem like a point that I can draw pretty accurately. So we can just start from there. So 16.5 or 6.5 right there. And then we have our slope, which is negative 1/2. So remember with fractional slopes, what we want to do is we want to go across by whatever the denominator says and then apply that vertical change according to the numerator. We also know that it's negative. So what that means is that every time we go across by 2, we go down by 1, like so. And we can actually define a bit more of a convenient starting point for this, just by going from here and plotting that point there. So this is essentially we have decreased by 0.5 here across a run of 1 is what we would say. But yeah, so then you can take from either point and then just go across, 2 across, 1 down, 2 across, 1 down, 2 across, 1 down, and so on. But yeah, so then that'll be more than enough points again to plot the line. So our line's going to look something like that. And that's going to be y equals negative 1/2 x plus 13 over 2. So our last pertinent information here is going to be our slope, which is negative 1/2, and then the y-intercept, which is 13 over 2. So then that's that. That's how you would plot these lines. And that's all the pertinent information that we would need. Any questions about that? Awesome. So that just leaves part B, which is identify using your graph where the two lines cross as a coordinate point. So if we look at our graph, we can see that there's one point where they both have the same value. and that's right here. So at this point, the lines cross over, and we call this the solution of these two lines. This is when they're equivalent to each other. So the two lines cross at the point. And what point is that? Well, it's got an x value of 3, y value of 5, so it's going to be 3, 5. And that's going to be the intersection. If you want to prove it, you can actually plug in x is equal to 3 into both of these equations, and you'll get y is equal to 5 for both of them. So that's just an extra proof that this works. This, we drew the lines correctly and we got the correct interception point. So that's good. Any other questions about that? Okay, great. So yesterday, I believe, you were working on a sheet that looks like this. Something like this. And it's called combining like terms. So